AI Podcast episode Browsing Like Human. Welcome to AI Podcasts. I'm Daniel, and with me is our listener and co-host Maya. Today we're unpacking an ACL 2025 paper titled Browsing Like Human, a multimodal web agent with experiential fast and slow thinking.
Hi, Daniel. I'm Maya. I'm ready. Give me the quick take first so I know where we're headed.
Here's the TLDR. The authors introduce WebExpertT, a web navigation agent that plans in two modes, slow and careful plus fast and intuitive, and it also learns from its own failures. On the Mind-to-Web benchmark, it outperforms previous systems, and in a live browser study, it slightly beats a strong baseline. In short, more human-like planning plus reflection leads to more reliable web automation.
That sounds promising. Who led the work?
It's led by Haohao Luo with senior author Ying Shen. The team includes collaborators from Sun Yat-sen University, MyLM Plus at Xiaomi, and Singapore Management University. The first author notes the work was done during a remote internship at SMU.
All right. So what exact problem are they trying to solve?
Automating real web tasks. Think of instructions like find pharmacy hours or book the cheapest train. An agent has to read the page, understand both the screenshot and the HTML, then choose the right elements to click or type in the right order. Recent agents can perceive pages and do some planning, but many still plan one step at a time, and they don't really learn from past failures in a way that transfers.
Right. So they follow instructions but don't build a sturdy plan, and they forget their mistakes.
Exactly. The authors borrow a familiar idea from human cognition. We use slow, analytic thinking when a task is new, and fast, heuristic thinking once we've built up experience. And we reflect on failures so we do better next time.
How does WebExpert turn that into a working system?
Two pillars. First, dual process planning. A slow pipeline extracts key constraints from the instruction and writes a structured step-by-step plan, what they call a golden plan. Then a lighter empirical planner is trained to imitate those golden plans so it can produce plans quickly during inference. Second, experiential learning. The agent keeps failures, retrieves similar ones when facing a new task, writes a short reflection about what went wrong, and uses that note to steer the next decision away from repeating the mistake.
So the slow process teaches the fast process, and the reflections act like little reminders. What does the system actually look at on the page?
It uses both the rendered screenshot and a simplified slice of the HTML. It ranks likely interactive elements and labels a small set as candidates, so the action generator can pick an element, an operation like click or type, and any needed value. In their in-context setup, they use GPT-4o to drive planning and reflection prompts, and for fine-tuning, they use models in the FLAN T5 family.
Got it. How did they evaluate it?
They use the Mind-to-Web dataset and test generalization in three ways: new tasks on known sites, tasks on new sites, and tasks in new domains. Offline, they report element accuracy and a step success rate that checks whether the right element and operation were chosen, assuming earlier steps were correct. They also run an online study in a real browser on 90 tasks with a human judge verifying task completion and updating time-sensitive details like dates before testing.
And the results?
3 quick points. First, at the step level, compared with a strong, in-context baseline using GPT-4o, WebExpertT improves by around 6 to 9 percentage points across those test splits. Second, in fine-tuning mode, the FLAN T5-based WebExpertT beats prior supervised systems like MindAct, CACT, AutoIntent, and WebGum. Third, in the real browser study, WebExpertT completes about a third of tasks, 33.2%, edging CACT at 31.5%, and well above plain GPT-4 or a straightforward fine-tuned model.
So it's not perfect, but it gets a meaningful share of tasks done end-to-end in the wild.
Exactly. The ablation studies explain where the gains come from. Removing deliberate planning or the whole planning module hurts performance. Dropping the reflection piece causes a smaller but consistent decline. Using only screenshots or only HTML also degrades results, so the combination matters. On latency, slow planning takes roughly 8.5 seconds, while the fast planner takes a few seconds. Human raters also found the slow planners' golden plans high quality, around 4.6 out of 5, and reflections were usually accurate and helpful.
Makes sense. You probably wouldn't want the slow planner running all the time in production.
Right, the slow planner is there to teach and to handle tricky cases. Day to day, you rely on the fast planner that has absorbed those patterns.
Before we wrap, what are the main caveats?
Several. The operations set is incomplete. Things like zooming or tab operations are not supported yet. Element grounding can be brittle on dense pages where labels overlap. Offline metrics assume a single reference path, even though there can be many valid paths. Most results are on one dataset, Mind to Web, so broader testing would help. There is no adaptive switch that calls slow thinking only when uncertainty spikes. And parts of the in-context setup rely on a closed API, which can complicate exact reproduction.
That's fair, and it sounds like the authors are upfront about those limits. I'm curious about the reflections. Do they really help, or is it just a nice idea?
They help a bit inconsistently. In the ablations, removing the reflection step knocks the scores down by about 1 point across the splits. It's not huge on its own, but together with dual process planning, it contributes to the overall lift.
Can you give a quick picture of what a reflection might look like?
Imagine the agent previously entered a generic product name and failed to find the specific model. It writes a short note like, "I was unsuccessful because I used a generic value. Next time I should enter the exact model string." On a similar new task, that note is included in the prompt and gently nudges the next action.
Practical takeaways for anyone building a web agent today?
Plan ahead in a structured way, even if you will execute quickly. Distill those careful plans into a faster planner so you get speed without losing coherence. And keep experiential memory so common, mistakes are less likely to repeat.
And what would you tackle next?
Add real-world operations like scaling and tab handling. Make element grounding sturdier by fusing visual and DOM cues. Evaluate beyond mind to web so we know how it travels. Improve offline metrics so alternate correct paths are recognized. And teach the agent to switch to slow thinking when uncertainty is high, ideally with open models for better reproducibility.
That's a clear roadmap. Final thought for listeners who don't live and breathe web agents.
Think of WebExpert as a way to bring two human habits into agents. We plan carefully when a task is new, then we speed up with practice, and we carry lessons forward when we fail. The gains are steady, and they show up even in a real browser.
I like that. Measured progress, grounded in how people actually think. Thanks, Daniel.
Thanks, Maya. That's it for today's AI podcast. If you found this useful, subscribe and share. Until next time.